Good afternoon, everyone. Welcome to our webinar today. We will just hold off for a couple of minutes until everyone can join us. Thank you, Sergey. Hello, everyone. Okay, so I'm going to kick this off this afternoon with our online webinar, Harnessing the Power of Digital Asset Management in the Solar Industry. My name is Hind Aliyev-Mensah. I am the Executive Director at the Middle East Solar Industry Association, also known as MESIA. We are the organizer of this webinar today, working in collaboration with SolarAbec, who's helping us with powering this content for you. We're very excited for this wonderful panel that we've put together. So I will start with Mr. Ahmed Ali, who is the head of digitization at NOMAC. He is joined by Mr. Rizwan Razak, who's the Chief Technology Officer at Huawei, along which you will find Mr. Ruben Lenhart, Executive VP Sales at Meteo Control, and finally, Mr. Ivan Lombardo Hernandez, the Product Manager at GPM, which is a DNV company. So just before we kick off, Middle East Solar Industry Association is pleased to welcome you today. We were established in 2009 and are the largest solar-focused association in the Middle East, and we are based in Dubai. We want to thank Huawei, Pure Energy, Sungrow, Aqua Power, Jinko Solar, who are our legacy partners at MESIA, and SolarAbec today. And welcome everyone, and thank you for joining us on this webinar. To kick this off, our moderator today is Mr. Monif Baraka, who is the CEO at SolarAbec.
Thank you very much, Hind. Thank you for inviting us for this webinar. Good afternoon, everyone. I wish to welcome you again to this webinar. I'm your moderator, Monif Barakat, and I'm thrilled to be here with you today to dive into the critical and timely topic of digital asset management, as it is playing a bigger role as we go within, especially within the MENA region. As we know, the solar PV operational capacity in MENA has been growing rapidly, crossing 20 gigawatts of operational assets in the region. And with that growth comes the need for greater efficiency and smarter management of assets. Digitalization has been a game changer in this regard, enabling operators and stakeholders to improve everything from real-time monitoring and predictive maintenance to economic evaluation and plant optimization. This is particularly essential in the MENA region, since these optimization efforts enabling the achievement of these world record LCOE numbers that we have seen in the region. And in order to achieve such low LCOE, you really need to optimize every part of your project, including the digitalization of maintenance and asset management of the plant. Today, I'm joined by a fantastic panel of industry leaders who will share their insights on how digital tools are being implemented in large-scale PV plants. Our speakers bring a wealth of expertise from companies like NOMAC, Huawei, Meteo Control, Green Power Monitor from DNV, and they will share practical experiences and innovations that are helping to drive efficiency and to lower costs in the solar energy landscape and improve and optimize the performance of the assets at the same time. We have a lot to cover, and that's why I really encourage everyone to ask their questions as soon as they get to your mind. Use the Q&A section instead of the chat section on Zoom. And if you are watching us on social media, then please drop your question as a comment as soon as you get that question, and don't delay till the end. We'll be organizing your questions throughout the webinar, and we'll be utilizing the last 10 minutes of this webinar in order to answer your questions. So without further ado, let's get started by welcoming the panelists today, and I'd like to ask them to kindly introduce themselves. I will start with Mr. Ahmed Ali. If you can please provide a quick introduction.
Yeah, hi. Hi, guys. My name is Ahmed Ali. I am associated with Aqua Power Nomac for now over 14 years. And currently, I am the head of digitalization, innovation, and our integrated management system within our Center of Excellence department in Nomac. And for all who doesn't know Aqua Power and both Nomac were formed in 2005, and Aqua Power is a developer, owner, and operator of power and water desalination projects. Today, Aqua Power has got about 66 gigawatts of power and about 8 million meter cube per day of water desalinated production, which makes Aqua Power the largest independent water desalination company in the world. And NOMAC was formed also back in 2005 in order to perform the operation and maintenance of all the Aqua Power assets that come into operations. Thank you.
Thank you very much, Ahmed Ali, for the introduction. You're very much welcome. We're looking forward to a great discussion ahead. Next, I'll move to Rizwan Razak from Huawei, please.
Thank you. So my name is Rizwan. I'm the CTO for the Middle East region, and with over 10 years of experience within Huawei. I've seen the development and growth of the organization over the last 7 years consecutively, being the number one inverter supplier, where we supply string inverters to the global market. We've accomplished one of the world's largest battery energy storage projects in Saudi Arabia of around 1.3 gigawatt with our organization Aqua Power in Saudi Arabia, and we are supplying digital asset equipment such as inverters, and always been driving the development of string inverters towards the market itself. And we've seen the adaptation of the string inverter market now favoring towards the other type of technologies available in the market. Thank you very much.
Thank you for the intro, Razwan. Very happy to have you on board. I'll move next to Mr. Ruben Lenhart from Meteo Control. Please introduce yourself as well.
Yeah, thank you, Munif. My name is Ruven Lenhart. I'm the Executive Vice President, Sales and Corporate Development, and the Managing Director of Meteo Control AMEA. Meteo Control, a global leading vendor for holistic monitoring and control solutions for solar PV, but also hybrid asset. What does it mean? So we offer complete monitoring hardware solutions for the assets on site, including power plant controllers, matching the grid codes and regulations all around the globe. And beside that, one of our core products is a software platform, an asset management and monitoring platform, which enables our customers to observe and monitor all their renewable assets, the portfolio of their assets around the globe in a very professional and efficient way. And I'm really looking forward to a fruitful discussion here today.
Thank you, Ruben. Appreciate it. Welcome on board. And then I'll move to Mr. Ivan Lombardo Hernandez from Green Power Monitor, the company of DNV, to introduce himself, please.
Thank you, Munif. I'm Ivan Lombardo, the product manager of the Smart Cloud in GPM Horizon. And in GPM, we provide the whole value chain, so from the installation and configuration of the SCADA system to the monitoring platform and reporting platform from a holistic point of view. So we not only try to focus on the technical analysis of the losses and what's going on in the plant, but also connect with the PPA prices, the market prices, and also make the most of our partnership with DNB. And we use and integrate the advisor experience and also other companies such as Solcas. So we integrate all that within our reporting platform.
Thank you, Ivan. Appreciate it. Welcome on board. I'm very happy to have the perspective of two of the major players in the digitalization sphere for solar assets, and we'll be definitely building a lot on your experience in here. I'll start with Ahmed Ali from Nomac Aqua Power. I'd like to invite you, please, to help us first of all and help the audience in general to understand why do you actually need digitalization for large-scale solar PV assets?
Thanks, Munif. I think one of the you can say the main reason why we really need digitalization in whatever we do is in relation to Aqua Power's commitment to provide the lowest possible tariff, uh, which is not only reliable but sustainable for our off-takers, for the countries and geographical locations in which we operate, and to help you can say the consumers, because the lower the electricity or water tariff is, it will be beneficial for everyone. Now, in order to do that, we are not now in a situation whereby we used to have a lot of, you can say, subsidies when you actually were having renewable projects. But now, over time, the tariffs have also gone lower to such an extent that, just to give audience an example of it, is that back in 2014, when we bid and won our first, you can say, solar PV plant of 200 megawatt in Diva Shua in UAE. At that point in time, the tariffs were about 8 to 9 cents per kilowatt hour, and we were able to provide a tariff of 5.84 cents per kilowatt hour. And then our lowest tariff has been in Saudi Arabia, where for a 600 megawatt plant, the tariff went down to 1.4 cents per kilowatt hour. Now, this probably gives you and the audience the kind of like, it is actually setting the stage of why do we really need digitalization, why do we need to have all these digital tools in order for us to be able to reach even one of our Aqua Power NOMAD goal, which we call it as manless PV and wind plant operation. And that cannot happen without the need of digitalization and its associated digitalization tools.
Okay, thank you, Ahmed Ali. I believe then you set the stage now that the digitalization is an enabler for such development in the industry to achieve such low LCOE, and making low LCOE is not just for the sake of having a low LCOE. Low LCOE means it's solar becomes more affordable and more competitive in the market, and that enables the transition towards a net zero economy, hopefully in the region very soon, especially with ambitious targets like we have seen in Saudi and the UAE. Now, I'll move to Rizwan. Based on what Ahmed Ali spoke about, like all these ambitions, so the developer is ambitious to digitize, so they would expect that the components of the PV plant become smarter in order to digitize, but at the same time, it should be at a lower cost, so we can also continue this journey of achieving lower cost of generation. And I think as you supply as I think I heard you once, you saying that there is one the heart of the PV plant, the inverter, and you have these two expectations that maybe some people would feel that they contradict each other. Smarter and cheaper at the same time. How can you achieve that? Like, how does the the product develop from your perspective?
I'll give a bit of a background on how we've entered into the solar market specifically. So entering the solar inverter segment market back in 2011, we very early stages adopted a string inverter concept into the solar market. And we've adopted that from 2011 onwards, where the scale of the string inverters were at the scale of at the capacity of around 20 to 30 kilowatts. Now we're seeing string inverters being available in the market between 300 kilowatts plus. So we've already seen a massive development on the power to weight ratio of these devices being drastically improved. Now, as you mentioned, digitalization. Now, as we've concentrated in the string inverter segment, we've ensured that bringing the core values of the inverter segment itself being improved internally. So ensuring that aspects of the string level monitoring functionality being improved, functions such as IV curve being incorporated as being a function which is available within the platform of the monitoring platform. And that can only be done with the necessary sensors within the devices themselves. So voltage and current sensors on the DC compartment of the segment of the inverter itself. So that has led us now towards having tools such as the inverters themselves having a very minimal amount of regular maintenance. So when we have developed larger capacity devices, we've also incorporated functions such as how is the cooling topology designed within the inverters themselves, and how can those devices themselves be minimized. As we can understand, and as we've all experienced, fans do have a particular failure rate. As we can understand, these solar assets themselves, they are with a life expectancy of 20 to even plus 30 years now. So having components which are going to predominantly fail more commonly, we need to adopt technologies and equipment within those devices themselves to ensure that they are with the life expectancy of the solar assets themselves.
Thank you for that, Rizwan. I think based on this, like you're speaking from the inverter manufacturer perspective, this dynamic development that happened over the years is something that is very important. And I want to complement that. I think I also picked up a question from the audience from Mr. Khalid Khashwar, who asked, what else is included in this digitization? So Rizwan spoke about the inverter. I'd like to invite first Ivan, please, if you, from your perspective, when we're talking about digitalization in a large-scale PV plant, what do we actually mean? Like if we try to break it down into components.
Well, I think the digitalization means that we need to combine all sources of information, because that's not doable otherwise. And for that, it's not only about the PV plant, as I was saying before. You can try to understand every technical loss happening within the asset, but that's not enough anymore. If you want to optimize the performance of the owner team, and if you want to perform the operation of the asset, you need to combine that with the prices in the market, but also with the forecast. So you want to go on and fix an issue in the plant, maybe you cannot do it if it's going to be raining. So that's something that you have to take into account. And in order to do that, you need to have all these sources of information and combine them together. So one of the most important ones is the SCADA, of course, but now it goes beyond the SCADA. And I think that's one of the key pieces of the digitalization here, in order to decrease costs and be able to be competitive with these low tariffs that are happening nowadays.
Okay, thank you, Ivan, for the answer. Rowan, from your perspective, would you say the same, or do you like to add anything?
I would like to add something. So Mr. Rizwan mentioned how Huawei tries to reduce the potential sources for failures, for example, to reduce the mechanical parts in the cooling topologies. And but At the end, the operation and maintenance companies or asset managers, there is still some work to do. Yeah, and in addition to that, our goal as Meteor Control is to reduce those efforts by automation. Yeah, so this, in my opinion, is the key nowadays, because one thing is to have very comprehensive and detailed data and parameters transmitted by or available through the SCADA system, for example, or a software platform. But then what to do with those data? So when I have to perform an on-site measure to replace or to fix a defective inverter, for example, I need to organize these things. And our mission actually is to automate those processes as much as possible, because due to the very, very low feed-in tariffs or PPA rates, Mr. Ahmad Ali has mentioned, also lack of labor is a problem nowadays, or lack of very well trained labor, and it doesn't make sense from economical perspective for very well educated and high skilled people to do very basic and repetitive tasks. Yeah, so this is our job, for example, to reduce those efforts so that the well-trained people can focus on the really essential things like the professional asset management and data analytics and so on. So automation to enhance the efficiency of the work, this is additionally a very important topic in our opinion.
Thank you for this, Reuven. I think I'll move this word automation to Mr. Ahmad Ali. Ahmad, if I may ask you, like you spoke about manless PV plants, and here Reuven speaking about automation. How do we, let's say, apply it practically? Because as a general term, we understand what it means, but today we have a lot of big plants. People go there from 8 to 5 in the morning to 5 in the evening, cleaning modules, fixing electrical issues, checking, I don't know, inverters, checking error messages, whatever. So how do you practically implement it, and what do you think are the quick wins in here to digitize and reduce manpower on the plant?
Yeah, I think the way we are approaching this is in terms of making sure that we have what we call it as a centralized pool of resources, and we have a central place from where not only we can monitor the plants, but we can also control those plants. And then we have a centralized pool of resources which we can utilize to then send them to various, you can say, plants within that geographical location in order to make sure that we have, you can say, the lowest manpower which we can deploy, however, without impacting the reliability and efficiency of our PV plants. Now, how do we do it is that there are various ways of looking at it, whereby, first of all, we are also whatever is the plant, whatever information is available in the plant SCADA, then we need to have that information coming out of that SCADA, and then we bring it to a centralized location, whereby we then put up those, you can say, predictive analytics solutions and performance monitoring solutions on it, so that we can try and pinpoint the fault in the field itself directly, so that once we identify a fault, then we can then send our, you can say, workforce just to ensure that they go there, they go to a targeted location. So we call it as a targeted maintenance. They go there, they attend that problem, and then they come back, or they kind of like move to another location in order to then also address the faults that we are going to have. Also, we are having solutions which are available, which were not known before, or if they were known, they were kind of like deployed on a very, you can say, not on an industrial scale, but maybe a very small scale. We now have fully automated robotic cleaning solutions where we have robots which are installed on the PV panels itself, and those can be programmed to operate as per our requirement, and then they can clean the panels, solar PV panels, without any, you can say, human intervention. I think one of our panelists, Rizwan from Huawei, they also mentioned about their string inverters. And one of the abilities of string inverter is extremely useful when it comes to IV tracing. So if we have that software available and we can use that software to do the IV tracing, then we also may not need to send people in the field and then keep on doing those IV tracings in the field. That automatically will avoid the need of additional manpower. Similarly, the other systems that we operate, whether it is our computerized maintenance management system, whether it is permit to work system, we are trying to have those systems also available through mobile applications so that people can do most of the work through their mobiles on the go, as opposed to doing that activity from somewhere else, and so on and so forth.
Ahmed, like you mentioned a lot of verticals, and I'll be referring to a lot to what you spoke now. It's very much valuable. I want to ask you, but for you, just a quick follow-up question. With so many systems that you have mentioned, when it comes to robotic cleaning, to smarter inverters that are capable of IV curve tracing, and mobile software probably for them, maybe integrated with the CMMS, how do you connect all of these systems together? Like, and not end up with, let's say, 7 to 8 islands, and their islands of data and processes that don't actually work together. So how do you approach this typically?
One of the way that we have standardized it across all the aqua power plants is to standardize it with an OPC server. And then once we have an OPC UA server where all the plant tags are configured, then it becomes easier for us to take that data and then bring it into our own cloud infrastructure. And then in that cloud infrastructure, we can host even third parties as well, who can provide us the value-added solutions in addition to building our own platform for PV, wind, and water desalination assets. So that gives us this flexibility that we can, we are trying to make sure that our solution, which we are preparing for our fleet, remains, you can say, OEM agnostic, so that once we have all the information available, we can then utilize them to have those kind of, like, as I was telling you before, predictive analytics and performance monitoring solutions on that. And then once we are, even for robots, we have these robot SCADA systems. And then we also try and now entering into a journey that we need to have all those, you can say, we may not be able to have all the robotic SCADA signals into the main SCADA, you can say, of the plant, because that may slow down the performance of the main SCADA system. But we just want to ensure that we have all the necessary signals integrated into our main SCADA systems as well, from the robotic SCADA servers and all, so that we can have, you can say, as much as kind of like one-stop shop to have all those information available. Another aspect of it is, for example, we call it as some applications that we have developed on the mobile, which is called as a digital worker application, where all the field rounds which any operator is doing inside the plant, it automatically gets digitized once he takes the readings, and then everything goes back into our enterprise resource planning system. And then that allows us to maintain all the history of all the, you can say, field operator rounds, as well as to see where exactly our operators are and our technicians are in the field, to be able to see and to gauge their, you can say, worker efficiency as well. So because it is fully integrated system with our enterprise resource planning system that allows us to then even fetch that information and then do further analytics as we need.
Thank you for that, Ahmed. I'll move this to Rowan, please. So Ahmed mentioned the different SCADA systems that you could have for the main SCADA system, for the robotic cleaning, for tracker as well, that could be in there. So you have so many sources of information in the end of the day in the plant. And you have many portals, yeah, like the inverter manufacturer gives you a system to log in and check. The same thing for the tracker and the robotic solutions. You get someone to inspect the plant with a drone, and they send you a username and password to another platform where you log in and with a lot of recommendations to do maintenance here and there, and there's a hotspot or a module to be replaced or shading or whatever. Your CMMS system is also giving you such kind of data, also instructions to do maintenance and all of that. So, and I believe also for you as a provider of a monitoring solution, like a comprehensive one, it becomes probably a challenge, yeah, like putting all of this together. So how do you handle this, and what value it actually brings to the owner of the plant?
Yeah, that's a very good point. It's a kind of a journey, let's say, and everything starts on site, with the hardware components. So when you want to implement a standardized and independent monitoring system like ours, like the one from Meteor Control, it all starts with compatibilities. Mr. Ahmed Ali mentioned all those different components you have, the tracker systems, the inverters, and so on and so forth. So one of the challenges for companies like Meteor Control is to provide the compatibility, so the software drivers, so that we can read out the data from all those different components. And this is really effort. So Meteor Control, for example, offers around 3,500 different compatibilities to almost everything which is on site, from inverter over trackers to energy meters, sensors, and so on and so forth. So, and then next step is where to transmit the data to. And as an independent vendor, we offer one centralized data lake, one centralized data platform, similar to what Nomag Aquapower is doing. So all the data need to be transmitted to one data lake. And then, of course, Meteor Control offers all the required tools to do the asset management, to do the operation and maintenance, to organize the workflows and on-site measures, and so on and so forth. But there are some customers having their own platforms, their own tools, and they don't want to switch from their SAP-based CMMS system to a Meteor Control system, but they want to use the Meteor Control asset management platform. So key nowadays is to provide interfaces. And this is also, we should never underestimate the effort which is required to interconnect different software tools or different software platforms. And this nowadays is also a big task. And last but not least, what about cybersecurity? So everybody is talking about cybersecurity, but when dealing with multiple platforms for the same asset, who is responsible to protect the data and who is responsible to secure the access to the data? So compatibilities, interfaces, open interfaces, and cybersecurities, in our opinion, nowadays is one of the biggest challenges.
Thank you. Thank you for the answer, Ruben. I want to move this to Ivan, because what Ruben mentioned is very important. So there is a lot of data in there, and it's put all in this data lake, or probably there are multiple terminologies for that, and secured. But my question now is how to make sense out of that, and how to actually make that, I remember you mentioned that in our preparation sessions, actionable, something that would actually help the team to do something about this data, and not just you piling up gigawatts of log files and probably hundreds of notifications from inverters from the site without making, obviously, if you have 10,000 inverters, every inverter throws you 6-7 notifications a day. You'd need an army to go and actually have do an action per notification. So how do you approach that from your side, Ivan?
Yeah, I think the two keywords here, it's automatization, as they have already said, and also customization. So of course you need to be able to work with different manufacturers, SCADA providers, and everything, because otherwise, you won't be able to provide a good service. So you need to make sense of all this huge data with now, string inverters, a lot of data there. So you need to automatize the workflow. So maybe you can trigger an alarm. That's the first thing you have to do, of course, but then you need to make that into a workflow. So you need to have a ticketing system and connect it with the CMMS and have all the data connected. So the O&M team is make aware of the issue, but the asset manager is easily connected with them. So probably then maybe you can open a ticket, and that ticket must have a chat box, or so they can have an easy communication. So the workflow is very easy. But also you need to customize. So in order to make something actionable with all this data, you need to understand what the user needs, and the needs changes everywhere in every asset in every country. So you need to provide the features for the user to customize whatever KPIs they want to be evaluating and whatever they want to be checking in that regard. So customization is definitely one of the biggest keys, because nobody have the same needs, and that's one of the most important features here, definitely.
And how do you, let's say, for you, Ivan, like let's say it's Green Power Monitor as a solution that you provide that tries to integrate all of that in one place and homogenize probably these messages, or in a way that is more user friendly. Now, can you, if I ask you for almost the same question, but from the perspective of the end user, we're talking about the plant manager, the maintenance technician, and the operations manager, the monitoring portal responsible, let's say, at the client. How do you make their life easier to better interpret and take an action based on what they see in the platform?
Yep. So for that, you need to write different points of view. The first one is, the technical one, how much you are losing from an energy point of view. Then, of course, you need to translate that into, the financial point of view according to the market data, how much you are losing from an economical point of view. And finally, how much that's going to cost you to fix it, how much it costs, to go to clean it, or how much does it cost to go and fix it. And with that, then you can say, hey, now it's profitable to go there and fix it. So there is not one answer, but you need to make a summary of all the information that you have there, and all those calculations must be done according to what it's written in the agreements, because otherwise it doesn't make sense, right? So that's the key here, being aware of the particular ways that they need to calculate their losses or their gains, and then according to that offer a summary of the view, and then provide, as I was saying, an easy way for all the different parties to work among them and have a fluent and a smooth communication, so everyone is aware of what's happening, how, and that's the way we have in GPN to provide that. So the interface must be simple but automatized and connect with all the parties involved.
Mm-hmm. Thank you for that, Ivan. I think we answered this question in details. I want to move to Rizwan. Rizwan, first of all, if you have a comment on what was said, please go ahead and comment on that. But
I'd
also,
like to just add one more
please.
point on that. I think that the vital aspect is, as these assets are becoming, especially in the Middle East region, larger in capacity, we're looking at, rather than megawatts, we're looking at gigawatt scale projects compared to other regions around the world. So the aspect of censoring the information on site is a lot of data. So obviously utilizing that data to the end goal, which is the purpose of gaining the electricity prices as low as possible. As we've explained from Aqua Power, they are looking at assets which are trying to provide electricity for its lowest price as possible. So it's utilizing that data, but also reflecting that with the historical information and utilizing algorithms to automate the algorithms to provide tickets to the systems such as the SCADA suppliers to ensure that it's a ticket which is with valuable information. It's not just data which is saying this is your error. And now, obviously, that operator on site then needs to then determine how are they going to rectify that issue. Now, obviously, they would be qualified to a certain level, but obviously there's going to be equipment on site which they may not be trained up to. So providing the necessary tools and action points on the equipment that and tools that they will need to be taking on site to get that problem resolved efficiently, safely, and with obviously the goal of getting that system back online as quick and efficiently as possible.
Thank you for this, Rizwan. Very important insight. And I wanted to ask you, like, if we here we're talking more about this reactive, let's say, part. We're hearing at the same time a lot of this predictive maintenance or getting a lot of intelligence about what our plant actually about the data that we have in our plant, and in order to use that data to enhance the performance. So for you, you have this feature of the IV curve tracing, I believe, from within the inverter. I would like to ask you, please, to tell us more about it, how it practically actually works, since it is relatively probably new, like 3-4 years old now, I believe. So it's already rolled out in huge plants. How do you see this making a difference in the plant?
Yeah, so I'd like to kind of bring down right from the beginning. Obviously, the inverters that Huawei has developed is focused towards the string inverter market specifically. So when we have been driving towards this string inverter segment, we've been having string level data available on the inverter points. So the data points have already been showing voltage and current values coming from the sites themselves. Now, with the traditional IV curve methodology, using manual labor, you're using expensive equipment and also downtime of the PV plants themselves. Now, all three of those obviously is a cost of associated with the OPEX of the PV plants themselves. Now, with the latest technology, which we say the last few years, but with Huawei, we've already had that available since 2017, 2018, where we've had IV curve tools available to our customers utilizing the online Fusion Solar platform, which is a Huawei data monitoring platform to assess the PV plant project data on site. Now, with that, we've adopted the IV curve, which is not only an IV curve from Huawei, but we've also gone with a third-party institute such as TUV, where they validate that the certain faults, the certain problems that are occurring on site are due to certain reasons. So we've analyzed how the curvature of an IV curve determines certain problems, and those third-party institutes have also validated that if the curve changes at a certain point of the performance, then that determines this is the issue on site. So that gives our customers and the end users clear and factual information on rectification issues. So when it comes to module cleaning, for example, as we discussed with Mr. Ahmed Ali, they've got module cleaning tools available on site, which can be automated. Now, we as a inverter supplier, and with the IV curve tools available, we could program the system to inform that the cleaning should be done at a specific time or specific day of the week or a specific month of the year. Now, that can minimize, obviously, cost, because doing it on a regular basis at a certain point of the day, if it's not functioning with additional data points on site, such as the weather station, there could be a forecasted storm coming into a particular plant at a specific time of the week or day, where we can put the whole system in a safe angle, which is the PV modules, the trackers themselves, and also the cleaning can be done based on the aspect of the storm potentially occurring on the particular site itself. So we could minimize certain aspects of the cleaning, but also utilizing factual information. So, that is where we really want to direct our value proposition here, is that it is not just pulling data and providing that data to SCADA suppliers, but also providing factual ticket information, which is based on historical information, which has been sourced and gathered from the historical plants that we have supplied our products for. Now, within the Middle East region, we are seeing plants going well over 1 gigawatt in scale. And this is, I've seen in Saudi Arabia, already occurring on multiple occasions. Now, having that much hundreds or thousands of string inverters on the site, is it necessary to have all of that information being pulled and displayed on a platform, which potentially, traditionally, the alarms would be just sent on an email or a text message notifying that this is the issue. So we need to be utilizing smart tools which can be pulling the data in a way where it can be informing the user on site to get it rectified safely and with the correct tools.
That's very important, especially, thank you, Rizwan, especially with plants being very remote in very remote areas, and you cannot afford dispatching crews like 2-3 times to solve the same thing. So the more accurate, more elaborate, and actionable, let's say, information we get from the system, the more helpful it is to actually fix it sooner. So this improves the availability of the components on the plants and all the performance metrics, and it saves costs as well. I'd like to move to Ahmed Ali, please, for a last part now, last round before we go to Q&A. And let's have a little bit more fun part, let's say. Let's call this part as a buzzword part, yeah. And my first buzzword that I directed to Mr. Ahmed Ali is AI. I remember one of the software companies that have a software to improve performance of PV plants once provided us with analysis. So we provided them with our plant details with the data. They got access to the power plant control and SCADA system. Took a couple of weeks. They run the system, and then they give us a very beautiful waterfall chart showing us where are we losing actually energy. We're losing, I don't know, 3% here, 1% there, and blah, blah, blah. And one of the very interesting, let's say, insights in there is that we were losing some energy because of snow in a desert area where it never snows. So, and then this is where it was a total, like, kind of, like when you watch a presentation, you just need only one mistake in order to disbelieve the whole thing. So it was like kind of super beautiful, super disappointing to see how AI helped to identify issues. So, like, what is your experience with AI? Do you implement it on daily basis, or you see that developing or something that could be useful in the future?
Yeah, I think that is AI is still remains a very interesting subject, frankly speaking. And I think the thing is, it's all about also expectations, what we expect to get out of that AI when we try and implement it. Again, I think one of the common mistakes that we all do is that when we put AI into operation, it all depends what kind of data has been fed in order for that AI to work. And if that sample data does not contain some of the information that you would want that AI to provide you, obviously, since that data is not there, so whatever AI you are going to put on it is not going to give you the results. So far, the portions of the AI, or you can say the parts of the AI with which we are working, is mostly related to, you can say, machine learning and advanced pattern recognition techniques, making sure that we can create you can say a digital twin of you can say various components of a PV plant and other plants, and then to be able to detect the failure modes and then see which are the sensors which contribute to that failure mode, and then have those machine learning models built in, so that on based on a good, you can say, historical operational data, so that once any prediction is going to come, we know that it is based on a good a fully trained model which has been trained based on the good operational historical data. On the other fronts of it, yes, we are using some of the features of AI when it comes to, but at the moment, most of the focus is related to the AI built-in features that are now available in many of the, you can say, platforms directly available when it comes to, say, Microsoft or Oracle or SAP and so on and so forth. So even today we are using Microsoft Copilot for it. We have developed a kind of like a chat bot, which we are testing now for legal and compliance departments. And then on the plant perspective, mostly we are focused on those, you can say, solutions on the predictive and performance monitoring, which I have just elaborated.
Thank you for that. Thank you, Ahmed, and you also mentioned one of the other buzzwords that I want to talk about, but I will get back to that a bit later. I'll move to Rizwan, please. Again, AI, in your opinion, where do you see that as a manufacturer of inverters and battery energy systems with EMS and this integration, hybrid systems, microgrids? So you have a lot of you have big portion of these smart components in your portfolio. Where do you see AI fit within your product offering?
Yep. So these sensors and AI equipment is already incorporated in our latest string inverters and PCS equipment that we are providing to the market. Now, those AI chipsets are built in to ensure that we are providing the value proposition to our customers. So when it comes to having the necessary sensors internally within the devices themselves. So what we have developed on the most recent terms is what we call the SDS, which is helping the incorporation of the tracker angle. So as the inverters already are censoring voltage and current parameters on site, we can also recommend what the tracker angles need to be in order to gain the most optimum energy generation values on site. Now, how does that happen? That's with the internal AI chipsets that are incorporated within the devices themselves. So this is something that we've already seen, being a leading ICT company well over 30 years now, and providing telecom equipment. We've already seen the shift in other segments around the world. And when we've come to the renewable sector within the solar PV, we've already seen that being a fundamental requirement. And when it comes to the battery energy storage, as you rightly mentioned, the EMS aspect, we are working in conjunction with those EMS providers to provide the most optimum LCOE and LCOS values to our customers, to ensure that they're getting a valuable product, also a product which is able to sustain the operation duration that is required by the asset itself.
Thank you for that answer, Rizwan. I'll move then to Rowan and Ivan, and you choose between you both as you feel comfortable between two buzzwords. Still, the digital twin is one of them. I'm not sure who would like to talk about that. How?
I would love to talk about both the AI stuff and in particular about the
Please go ahead.
I would assume Ivan would love to do the same.
Yeah,
Ivan,
correct.
do you want to talk about the digital twin, and then I would talk about how to utilize AI in the operations, maybe just
feel comfortable both, I think, to comment on that. Let's start with Ivan and then we'll move to Rowan, yeah?
Yeah, with data twin, I think there is a trend going on saying that data twin in PV assets, most people understand that you just have like a nice map of your asset and you see where the issues are happening, but that's not really what a data twin usually means. With this, that you create a model of your plant and it's more like a machine learning. So I don't know, Monif, what you were referring to with this data twin, but in any case, I will talk about both again. So for the first one, I think it's an interesting approach. It's more visual. It's more convenient, especially for small plants. I don't know how that's going to fit. For huge assets, nowadays we have 1 gigawatt, almost 2 gigawatt assets. So how are you going to be, making use of that visual diagram? But in any case, it's something that is it's been requested by many asset owners. So that's something that plays a role. But I think it's more interesting the other one, of course, and more close to AI. So there are different outputs there. So first of all, you can do the data will of, for instance, your inverter or even your whole plan, and then you translate that into a predictive tool. So you try to predict of all the issues that can happen, and benefit from the fact that you won't have an inverter and the breakdown because you will know in advance, and then you will be able to avoid that breakdown time. But there's a lot of potential outcomes that we can create here with AI. So for instance, what about budget generation? So most people work with 8760s that was done by an AI a while ago, and maybe that was not accurate enough, and they are permanently going below budget every year because maybe it was done wrong, or maybe it was not perfect. But now you can use machine learning to try and create the actual budget that we'll have. So maybe you're not going to replace it, but at least you are aware of how much you're going to be producing on a yearly basis constantly. And then we have the fact that now asset owners have a lot of DC power, and that's a lot of information. So you can try to gather all that information and couple the production, the location, the weather, the manufacturers that you have there, the devices, the models, and then try to have an estimation of how much you are going to generate, or how reliable it is, a given manufacturer in particular in a given location. So maybe a given manufacturer works better on the desert, and another one works better close to the coast because of the impact of the sea. So all that data, if you are able to input into a machine learning algorithm, could be useful to not only help in the current management of the assets, but also helps you estimating how the future ones are going to perform.
Thank you. So you're transferring knowledge from plant to plant, even like as you go, having, let's say, more collective, let's say, intelligence in here in order to support the rest of the portfolio. Thank you for that, Ivan. Rowan, from your side.
Yeah, first, I totally agree with the most of the things Ivan has mentioned. One key aspects when talking about the digital twin. So in the past, all the vendors spend a lot of effort to visualize data. And Ivan mentioned a digital twin showing a copy of the plant with the strings, how they are built, and then colors indicating the behavior, situation, and so on and so forth. But nowadays, it is way more important on how to utilize the data instead of visualization. And using the digital twin, the outcome of the digital twin is to tell the user on what to do. Don't show the customer or the user a string turns from green to orange or over orange to red. The user wants to know what to do. Yeah, so this is nowadays way more important. And then when talking about AI, everybody is talking about AI. At the end, it's machine learning. And what is required to use machine learning algorithms? It's data. You need a huge amount of data. So when following the media, the tech media, OpenAI and all these companies, what they are talking about is where to get data from. Yeah, so they are all using Reddit, they are reading the internet and so on. So what Meteor Control has, for example, is we have millions over millions of alarm messages. We are doing that job for 25 years now. We have more than 60,000 plants around the globe. So we have tons of data, especially alarms. When we talk to our customers, what is one of their key pains in the day-to-day operations? Most of them answer, at least in the top 3 priorities, it's the amount of alarms. Yeah, because for each and every alarm, they need to take care for. So our objective as one task in our development of the product is to reduce the amount of alarms. And therefore, we can use AI algorithms. Let me give you an example, a very simple example. There are plenty of alarms which occur every day or every week or every month due to the same root cause. A super simple example in C&I rooftop applications is the plant is partially shadowed because there is a tree in front of the roof, as an example. So do I really need to see that particular alarm each and every morning when I turn on my system? No, I don't think so. So let's use machine learning algorithms to not to show this alarm anymore. And then in the next step, to prioritize the alarms based off different parameters. For example, as Ivan mentioned, economical aspects become more and more important. So it is downtime of a plant, it is the losses in yield, but also what does it mean in terms of economics. Yeah? So this is what the user wants to see. They don't want to see fancy graphs anymore. They want to know what to do. And they want to know what does it mean for my calculation, for my budget. So our goal is to utilize AI to lift up the operational excellence to the next level. So this is key in our opinion.
Thank you for that, Rowan. I really appreciate that input all from your side and from Ivan's side as solution providers that actually more or less that's the interface in front of the customer where that should make sense out of everything. And I really like this discussion about how to become smarter, how to avoid repetitive alarms, how to make them actionable, how to probably group them into certain groups so we all understand the scale of work that has to be done, and this will help plant managers to plan their work much better. We have reached the end of the session. We are 3 minutes off of the webinar today. I tried to embed the questions that I received in the chat throughout the session, and some of the questions actually were automatically answered by our panelists today. So I think we are all covered for today. I really wish to thank all the attendees that have been with us today for staying with us for this session. I invite you all to keep coming back. Mexia organizes tens of events annually, whether it is online through webinars or in person. There's an upcoming in-person event for Mexia in Tunisia. If you are in Tunisia, welcome. You're welcome to join us in there soon. And please, the team has shared the website in the chat, so you may also join, check the website and see and sign up to the upcoming events. I wish to thank my esteemed panelists today, namely Mr. Ahmed Ali, Head of Digitalization at Nomac, an aqua power company, Mr. Rizwan Razak, who is the CTO of Huawei, Mr. Ruben Lenhart, who is the Executive Vice President for Sales at Meteor Control, and Mr. Ivan Lambardero Hernandez, the Product Manager for Green Power Monitor at DNV GL Company. Thank you very much for your time today. I wish to thank Hind, who started the session now today, and also Amir and Malak, who have been working on the background to also support in this event. Thank you very much, everyone, and hopefully we'll see you all soon in our upcoming webinars. Have a good day.
Thank you. Thank you.
Thank you very much.
Thank you. Yeah,
Great
thanks.